Alright, so my first solution for problem 4 was rejected because YouTube said it was too long, and it was pretty long. So I'm going to try to do this a little faster. This is the one where we have a ball shot from the ground up into the air, and we're given its velocity at a height of 9.1 meters, and then, or when it's, hits 9.1 meters on the way up. So there's our ground, and the ball goes something like that. And so at a height of 9.1 meters, the velocity is observed to be blah, 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 blah. So right here, at this point in time, we're given our, some velocity, which I'm going to call, I'm going to call this V naught. And I'm going to call this distance here, I'm drawing in purple, H naught, or, what do we call it? I want to call it Y naught. This distance here, I'm going to call X naught. And so that's just its initial position. So X naught is given, or X naught is not given, we don't know it. Y naught equals 9.1 meters in this case. And V naught for me equals, let's see, 7.7i plus 7j meters per second. 7i hat plus 7j hat meters per second. So, and they want us to find out all kinds of interesting things about this. So let's start with part A. To what maximum height does the ball rise? So, we've been given Y naught and V naught. We want to find the maximum height it rises to. So we can call that, say I draw that here, and make that Y max. We want to find that. So, well, probably the easiest way to do this is to look at, it's going to have this change in height there. So, yeah, you know what? Why don't we do it this way? Let's find at what time its height reaches 0. So, velocity in the y direction is v y naught plus the acceleration times time. But acceleration here is negative g, because this is our acceleration due to gravity, h sub g, so vy equals vy naught minus gt. And so we want to find at y max, vy, the velocity is going to be purely horizontal, because that's the way projectile motion works. As it comes up, when it reaches its peak, it's just going horizontally, so vy is going to equal 0 at that time. So vy naught minus gt, and then the time when that happens is just going to be vy naught divided by g. So once we know that, what do we want to find? We want to find its maximum height. So it's y. We want to find the height at this time, and really that's what it is. So y equals y naught plus, and this is just your standard equation for projectile motion, in the y direction. So initial y plus your initial velocity in y times t minus 1/2 g times t squared. This is just your standard, and so that's going to equal, well, we were given y naught, and then vy naught times t, so y max, I'm going to say here, is y naught plus vy naught times t, and t is vy naught over g, so plus vy naught squared over g. That's vy naught times vy naught over g, and then minus 1/2 g times vy naught over g, and then we square that. So really everything inside gets squared. And what happens then is you get equals y naught plus vy naught squared over g, and then this, you have this g squared down here, and that cancels with 1g here. So this becomes minus 1/2 vy naught squared over g. This here is the same as this, so you're subtracting 1/2. So what this really means is that y max equals y naught plus 1/2 vy naught squared over g, and that's going to be our final answer. So if we take the numbers I was given, let's see, I'll do this in, how about a little Kelly green sort of thing, or dark green. Maybe it's a forest green. So using my numbers, y naught was 9.1 meters, and then we're going to do plus 1/2, and vy naught, so the y component of this was 7j hat. So times 7 squared, that's 7 squared, over 9.8. Okay, so what that's going to equal is, should be pretty easy to find. So I'm going to use my Windows Power Toy calculator. This is a pretty neat little thing. If you're using XP, unfortunately I don't have one for Vista or Windows 7, but this is a pretty neat thing if you're using XP because it's sort of an advanced calculator. So 9.1 plus 1/2 times 7 squared divided by 9.8, and enter, and that equals 11.6. And so, see, it's nice because you can just type in whatever you want, and then it has a little history. So, 11.6 meters. Okay, so that wasn't terribly painful, was it? Let's input that, make sure we're doing this correctly. So, bring our little window Rooney over there, and 11.6 meters, our maximum height. And where is it? There we go. What total horizontal distance does the ball travel is our next question. So, to find that, first we want to find the total time in the air. So, for B, first, we want to find the total time in the air, and it's pretty easy to just take that and multiply by the horizontal velocity, because we know that's constant in this projectile motion. So, really, that's the time it takes. I mean, how do we find that? Let's find the time it takes to hit the ground from here, and then we know it's symmetric. So we find, imagine hitting the ground there, and it started here and came up, and so we know at this point where we're sitting. And so it takes some time to hit the ground there, and it takes some time to go up at the same time, and we can find all these things out. So T fall is what I'm going to call it, but really, it's just half of, I'm going to say it's 1/2 of big T, where big D is the time it takes to go from, one side to the other. So T fall, let's change colors again just to keep things interesting, is 1/2 T, and that's going to equal the time it takes to go from Y max to the ground. So let's say at let's set a new initial conditions here. Sorry, let's set a new initial condition here where Y naught is Y max, and then YF is 0. So YF is, at this point this is F. So Y max, its initial vertical, now we're defining here as our initial condition. Its initial velocity is purely horizontal, so there's no initial condition term or initial velocity term here. So we're just going to say minus 1/2 GT squared. Actually, that's a capital T. So this is the, I'm sorry. No, actually that's T fall squared. Okay? So that just means Y final, we just want 0, the ground, equals Y max minus 1/2 G T squared time to fall squared. Okay? So what this really means then, we can just do a little rearranging. So we can say 2 Y max over G equals T fall squared, and then so that means T fall equals square root of 2 Y max over G. And what is that for our numbers? Well, 11.6, 2 times 11.6 divided by 9.8 and the square root. So 2 times 11.6 divided by 9.8 equals blank. No, garbage prior to the whatever. 2 times 11. So let's hit enter there. There, that's our time it takes to fall. 2 times answer is that. So basically what this gives us here is that capital T equals, and what did we get? I forgot. Capital T is 4.73. Yeah, 4.73. It's 4.73 seconds. And then, so what's the total distance it travels? Well, the velocity in x. Let's come back over. Oops. Let's come back over here and let's do this now. I don't know. Let's go back to let's go to red. Okay. So velocity in x is constant, and so the distance traveled is just that velocity times the time it's in the air, which equals, if I recall, 7.7, right? 7.7, and then the time is 4.73 equals so let's do answer times 7.7 is 36.5 meters. So that's going to be 36.5 meters, we hope. Does that sound right? Well, nothing for it but to okay, well, nothing for it but to try. 36.5 meters. Let's see, 36.5. 36.5. Total horizontal distance the ball travels. And so, what did I do wrong here? I said it's going to travel, it's going to spend, the time it takes to fall was 2 times y max over g, right? And y max, if we got that right, was 11.6 meters. Divided by 9.8, so there should be been about 1.2 maybe. Times 2 would be 2.4, and then the square root of that. Oh, you know what? I forgot to square root, I bet. Yep, okay. So, I'm just going to do this. T, I'm going to find a variable capital T, 2 times square root of 2 times 11.6 slash 9.8. And, okay, so T equals that. And that's what T is. So now T times 7.7 then gives us 23.6 meters. That sounds a little, or 23.7 meters. That sounds a little more reasonable. So let's try 23.7. 23.7. And boom, there we go. Okay, so that gets us halfway through, and I'm going to stop there and then do this.